Okay, students. This is the second day of our rational notes taking. Okay, reminding that we have the 5 letters R, A, T, E, and Y that are finding our 5 properties or our 5 attributes of your rational functions so that we can graph, right? Our whole entire point is so that we can graph these things. So there we go, reading them. We have, of course, roots, where it crosses your x-axis. Your vertical asymptotes come from your denominator. Your table tells you the graphical behavior around your asymptotes. E refers to the horizontal asymptotes. Okay, so there's 3 types: top heavy, neutral, or bottom heavy. And then Y is your y-intercept. Plug in 0 for x. Okay, so let's move on and let's try. Here's number 4. X squared over x squared minus 4. Okay, roots come from your numerator only. So sum of values squared equals 0. What number squared equals 0? That would, of course, be 0. Okay, so first we have your x-intercepts. We have an intercept at 0, so we come down to our graph, and we put a dot at the origin where x equals 0. Okay, next we have our asymptotes. Our asymptotes always come from your denominator. Every single time we have an asymptote, we are figuring out what numbers to not allow to go into our denominator, right? Because we can't have a 0 in a denominator that is an undefined function. So we will solve this by adding 4 to both sides, right? And getting x squared equals 4. And then when we square roots, we get 2 values. We get the positive, of course, but we also get the negative. Okay, so remember, always, when you're taking a square root in an algebra course, you get a positive and a negative answer. Okay, and I say in an algebra course because in geometry, right, if you did it in geometry is only concerned about the positive value because you can't have a negative angle. But this is an algebra course. So we take positive and negative 2 as your vertical asymptotes, and we draw in some vertically dashed lines to represent that. And now comes the tedious part, making our table. Okay, so our table consists of what's going on the number negative 2 and what's happening around the number positive 2. So we plug in some values. Okay, so we're going to use negative 2.1, and that's green. I don't know how well you can see that. Let me change green to purple. Let's plug in negative 2.1 and negative 1.9 and see what we get. And then we'll plug in positive 1.9 and positive 2.1 and see what we get. Okay. Remember, we are going into our equation. So negative 2.1 squared divided by negative 2.1 squared minus 4. Okay, same thing for all 4 of these values. So let's get to the nitty-gritty here. If I were to square negative 2.1, that is a positive value, for sure. Okay? And then here, negative 2.1 squared is also a positive value. It's like 4.4. So 4.4 minus 4 is another positive value. So a positive divided by a positive is a positive, which means the graph is going to be going up on the left side of negative 2. Okay? Negative 1.9, always a positive. Squaring things makes them positive. Okay, 1.9 squared is like 3.7. 3.7 minus 4 is negative. A positive divided by a negative is a negative, so your graph is going to go down on that side of negative 2. Okay, this is what we're doing with our table, is we're trying to decide whether we have positive or negative values to see whether our graph goes up on the asymptote or down at your asymptotes. Okay, so all we're worried about is positives or negatives, and you can use your calculator to help you figure this out. Okay, you don't have to know how to do 1.9 squared in your head, but you should know that squaring something makes it positive. Always, always, always. So let's go to our graph. We have an up arrow on the left side of -2 and an up arrow on the right side of +2. And we have down arrows on the right side of -2 and on the left side of +2. Okay, so here are our attributes so far. We have 2 vertical asymptotes. We know where our graph goes along those asymptotes, and we know our x-intercept. Okay, E stands for horizontal asymptote, or end behavior. Okay, so we have x squared over x squared, which means we have a neutrally heavy graph. And when we have a neutrally heavy equation, we look at the coefficients to find the horizontal asymptote. Okay, 1 divided by 1 is 1. So we have a y equals 1 horizontal asymptote. So we plug that in here, right? We put a nice horizontally dashed line representing the y equals 1 horizontal line. All the way from left to right. And our last step is finding the y-intercept. So you plug in 0 for all of your x terms. So we have 0 squared over 0 squared minus 4, which is 0 over -4, which is 0. So our y-intercept is here, the same as your x-intercept. So now what's left is just making our graph. Okay, so it looks like it starts on the left side of -2, and we're going to curve out to y equals 1. Okay, same thing on the right side of +2. It curves out nicely, right, nice and smooth. I'm not really concerned about the distance there, but just make sure it's nice and smooth. And then in the middle, our graph is going to be parabolic-like, parabola. It's going to be a U facing down. And that is your answer, right? So all of these graphs, all of these rationals, we are just trying to sketch a graph of. So we have all 5 of our attributes that helps us do that. Okay, let's look at number 5. Starts off with, let's see, we have a quadratic in the numerator and a linear in the denominator. Okay, so when we solve, right, find the y, or rather the zeros, you're going to take your 2x squared plus 5x minus 3 and set it equal to 0. Okay, so here we have ourselves a quadratic. So we solve quadratics by factoring. So let's see all the different ways that we can factor. Okay. First of all, we need to do AC. Right, so 2 times -3 is -6. So we are looking for numbers that multiply to give us -6 and add to give +5. Okay, those numbers are 6 and -1. Now, what we do with our 6 and -1 is we split your 5x into these 2 values. We split it into a 6x and a -1x. Okay, so this is one way. We're going to factor this one by grouping, so this is a way to do that I haven't shown you guys yet. But this is the way that Harlan does it here at this school. So this is the way that we can do it too. Nothing wrong with this method. So we group these 2 things together. What do 2x squared and 6x have in common? Right, they have a 2x, leaving me with an x plus 3 as a leftover. And then what do minus x and minus 3 have in common? Right, negative, so a -1. Right, we make sure that we have a number there, not just the negative symbol, but rather a -1, which of course changes our sign to a plus x and a plus 3. So now our 2 x plus 3's get together as friends, right? One friend group there. So we have one factor of x plus 3, and our other factor is 2x minus 1. Okay, so this is how we're going to solve this quadratic, is by factoring it. And this is one way that we can factor, by splitting up your middle term. Okay, split up your middle term. So now if we set each of these factors equal to 0 and solve, now we can figure out what your x-intercepts are. Okay, so it turns out that x equals positive 1/2 or negative 3. Okay, let's look at our vertical asymptotes, right? That just comes from your denominator. X plus 3 equals 0. So x equals negative 3. So let's go down and put these on your axes down here. We have an x-intercept of 1/2. So if that's positive 1, then positive 1/2 is right in there. And then we have negative 3, negative 1, negative 2, negative 3 is your other x-intercept. And then we have your asymptote that also runs through negative 3. Okay, and this should be cause for concern for you. Can we have an intercept where there is an asymptote? Okay, no, we cannot have an intercept where there's an asymptote. The asymptote is one of your restrictions, right? We can't use negative 3 in your equation at all, or we're going to have an undefined value. Okay, so this is going to tell us that something weird is going on. Whenever we have an intercept where there's an asymptote, there's something weird going on. So notice here we have a negative 3 and a negative 3. This means that we can factor and simplify your original equation. Okay, factor and simplify. So let's take a moment to do that so that we can figure out exactly what it is that we have to graph. So we did our factoring already. That's 2x minus 1 and x plus 3. And your denominator was x plus 3. Now, this is your original function that came from 2x squared plus 5x minus 3. Okay, so we factor it, which we already did to find the zeros. Okay, and now what can we do to simplify? Right, we can divide this. X plus 3 divided by x plus 3 is 1, right? Anything divided by itself is 1. So we are really just looking at the graph of 2x minus 1. Right? That is what we are graphing here. So our graph is not going to look like your traditional rational graph with asymptotes and approachings and vertical things like that. It's going to look like a line. Right? This is a linear equation. In fact, it's going to look like a line with a hole in it. And that hole is going to happen whenever your line crosses your x equals negative 3 vertical asymptote. Okay, so let's continue on down. That's an important thing to understand. Right? This is a weird one. So because it's weird, we don't do a table because we don't have any approaching like you normally would for a rational function. So we don't do a table. It is definitely top heavy, right? We have an x squared on top and an x on the bottom. So our rational function is top heavy, which means there's no horizontal asymptote. Okay, none of that stuff. But we can still find out what your y-intercept is. So plug in 0 for everything, and we get 2 times 0 squared plus 5 times 0 minus 3 over 0 plus 3. Right? All these times zeros cancel out because 0 times anything is 0. Negative 3 divided by positive 3 is negative 1. So our graph crosses the y-axis at negative 1. So remember, we are graphing the line 2x plus, or rather 2x minus 1. Because that's what we got when we simplified, we factored, and then we canceled out the x plus 3s. They divided to give you 1. So this graph has a slope of 2, right? So there's your up 2 right 1. That's the slope of a positive 2. But also down 2 and left 1. And whenever we get to the x equals negative 3, we're going to have your hole. Okay, so that's how we figure out where your hole is by doing the Algebra 1 graphing of your linear equation. And of course it goes off to the lower left also. right? This is one of those weird rational equations. Okay, and you can tell it's weird because we have an intercept where there's supposed to be an asymptote. All right, our last example, number 6. Right, this is the closeout one from our book. We will do many of these whole entire things one day at a time next week. So roots, are there any roots? No, right? You put your numerator equal to 0. Does 1 equal 0? No, it does not. There are no x-intercepts, no roots. Okay, vertical asymptotes. We set your denominator equal to 0. So x minus 1 quantity squared equals 0. So we solve by square rooting, right? Square rooting makes it go away. What's the square root of 0? 0, of course. So then we add 1 to both sides, and x equals 1. So we have a vertical asymptote at positive 1. So there we have your vertically dashed line through positive 1. Okay, just like that. So now let's make our table. Positive 1 was your asymptote. So we're going to pick a number close on the left side, like 0.9. And we're going to pick a number to the right side, like 1.1. So what's 1 over 0.9 minus 1 squared? And what's 1 over 1.1 minus 1 squared? Okay, so inside of your parentheses, we get a negative 0.1, but negative 0.1 squared is a positive number. And 1 over a positive is a positive, so the graph will go up on the left side. And then 1.1 minus 1 is a positive squared is also a positive, so our graphs will be going up on both sides of your asymptote. Okay, up on the left side and up on the right side. So 1 over x minus 1 squared is, hopefully you recognize it as being clearly bottom heavy because there's no x in the numerator. So y equals 0 is the equation of your horizontal asymptote. So we plug that in here. It's along your x-axis. All of that goes there. Okay, bottom heavy because we have an x squared in the denominator and no x in the numerator. And your y-intercept, 1 over 0 minus 1 squared, is 1 over 1, which is 1. So this will cross your y-axis at positive 1. So this graph is going to look like a really skinny volcano, right? Because both of your arrows go up, and it has to go through positive 1, right? Flattens out to the left. And then similarly for the right, it has that same type of a curve to it to get you your 1 over x minus 1 squared graph. And that is the end of the notes for rational functions. Have a great day. Goodbye.